Hello, welcome, and thank you for joining us once again. Talk to my car, where we make your cars talk, and we want to teach you a few basics of you making your cars talk to you as well. Today we are going to deal with the basics to anti-lock braking system operation. Now, most of you who own cars made from around 1992 onwards, most of them will have ABS operational. You might have seen the marking, stuff like ABS written somewhere on your vehicle, but you had no idea what it's about, or if you did, you don't know how it works. Well, today that's what we're going to talk about briefly, just the basics. Now, ABS, in short, stands for anti-lock braking system. Now, locking means, when you're talking in wheel or brake speak, locking means having the wheels not spinning anymore. Usually when a vehicle is traveling, the wheels will be spinning. When they lock but the vehicle continues to move, most of you in Uganda you call it sliding, but it's locking is a better term for that. Now, to understand how the system works, we shall have to examine the braking system on a car. On a car without ABS, the image here is showing you a car with ABS, but on a car without ABS, I'll point out what you have on the vehicle. You have this brake pedal, and you have a stop lamp switch somewhere here. That's the one that turns on the brake lights at the back of your vehicle to warn following drivers that you're braking. And we have the master cylinder here with a small reservoir for brake fluid. And then on a car without ABS, from here you'd have 4 pipes going directly to the brake discs, to the brake pads at each of these wheels. And the brake pads will, when you step on this pedal here, it will push the brake fluid in here, which will push against the brake pads, and the brake pads in turn, the brake pads at the wheel will in turn push against the brake discs or the brake drums for vehicles which have brake drums on the rear wheels. Some vehicles, especially the sporty type, have brake discs in the rear as well, but most will have brake discs in the, rather brake drums in the rear. But usually most modern vehicles will have brake discs in the front. So when you, once again, when you step on the brake pedal, you are pushing against the brake fluid in this master cylinder, which will, this brake fluid distributed through the entire brake system will push against the brake pads, which will push against the discs or the pads. Now, on a vehicle with ABS, you have this system once again, then the master cylinder, and then between these pipes leading to the wheels, to all the wheels, you have a hydraulic modulator. Now, that's very important. That's the difference with ABS. Now, you have the modulator, which will modulate the pressure of the brake, which will modulate the brake pressure going to all the wheels. Now, the brake modulator will work on the commands of the ABS control module or the ABS computer, which will depend on the sensors, on the wheel speed sensors at each of these wheels. You have one here, right hand front wheel speed sensor, another one here, another one here, and another one here. Now, I hope you've got the basics, and on top of that, you have the ABS off warning lamp on your dashboard. When the system is faulty, when the ABS control module has detected a problem with the system, it will turn this light on to warn you the system is off. When the system is off, when there is a problem with the ABS, it doesn't mean the car will not be able to brake. It will still brake, but it will brake as if it doesn't have ABS. I'll explain in the next slide how ABS works. Basically, what you're having, what this modulator is doing based on the instructions from this computer, from the ABS computer. If you're going down, say, a rough road, or a road that's a bit slippery, and you have the wheels, some of the wheels are planning to lock, because all the time when the vehicle is moving, this computer will be monitoring what the sensors on each of these wheels are giving it, and it will want to see similar speeds all around at all these wheels. Now, if one of these wheels, either, which is what happens in most cases, begins to slow down more than the other three, this computer will understand. If, for example, this wheel, the speed sensor, this wheel started to show reduced speed compared to all the other three, this computer here will understand that this wheel is about to lock up. What it will then do, that's this computer here, it will instruct this modulator to ease the pressure, the brake pressure on this pipe, because there are 4 pipes running from this modulator, one going here, one going here, one going here, one going there. Now, this modulator, based on the instruction from the computer, can control the pressure in any of these wheels at the pressure it wants. So, for example, if this wheel is planning to lock up, this computer can instruct the modulator to reduce the pressure, the brake pressure on this wheel, so that it stops planning, or it stops to lock. It prevents it from locking. Now, as soon as the wheel speed here is corrected on this wheel, it is comparable to these others, it will release that wheel. It will release the full brake pressure from here to that wheel. When it notices now this wheel is planning to lock, it will do the same thing to this wheel using this modulator. Why do the manufacturers do this? Because if you brake very harshly and the conditions are slippery and the wheels started to lock up, 2 things are going to happen. You're going to lose the ability to steer, because when the wheels lock, the car can now go in any direction it wishes. It will just follow the Newton's laws of physics. It will take the using momentum, it will take the best path it pleases, depending on your velocity and directions and direction you are traveling at when you commence the brake. And in most cases, that's not what you desire. For example, if you have a cow standing in the road and you are trying to dodge it, and the car initially was traveling aiming at that cow, if you begin slipping, if the locks wheel and you begin slipping and the wheels begin to, and the wheels lock up, you continue traveling towards that cow and you will eventually hit it. Now, with ABS, if the computer prevents the wheels from locking, you will now be able to steer. You can now steer. When the wheels lock, your steering input will be quite useless, because the vehicle will take whatever direction it's wishing to go using the laws of momentum. But with ABS, because the wheels are not locking, you are still braking, and you are also able to steer. So you can steer around a cow, for example, and safely avoid an accident. Now, moving on to the next slide. Here, I will show you how the wheel speed sensor works. The wheel speed sensor is a very important component of this entire system. We have the computer which controls everything and is listening to the sensor. The computer is important, the modulator is important, but they all base their actions on the input from the sensors. So I'll try to explain to you briefly how sensors work. Now, sensors work, most ABS sensors work typically like a magnetic camshaft or crankshaft position sensor, which will have a magnetic circuit in here which generates pulses. When metallic or magnetic teeth pass its face here. Now, what happens? This reluctor with teeth in it is typically what you find in the wheel assembly for each wheel, and that will, in most cases, affect the magnetic field in this area, and the sensor senses that, and the result of that, it will generate a signal which will be carried to the ABS computer. Now, the signal will be in that form. There will be voltage changes like that. You have 0 volts here. Now, this sensor will create an AC kind of AC current, an AC kind of voltage. If you are aware of how AC is the opposite of DC voltage. AC means alternating current. DC is direct current. Now, if you have an alternating voltage between, say, -2 here and +2 here, or -3 here and +2 here, being created by this sensor, you end up with this sensor when this reluctor is passing, when the wheels are rotating and this reluctor is passing and its teeth are passing the front of this sensor, you have a voltage that will be in that format. It will be behaving like that. Now, the computer will be seeing these signals and counting the time between these peaks. The shorter the times become, the faster you are driving. So it will accurately determine your speed according to the calibration that it has in its memory. So it can tell when you're going slow, when you're not traveling at all. It will know. It will not see these signals, and when you begin traveling, it will count the time between them, and it will be able to tell the speed. So basically, that's how that works. And briefly, I like to use wiring diagrams to explain how these systems work, because wiring diagrams are able to give you a general picture of all that's contained in enabling a particular system to work. For example, the ABS system, I took this from a factory service manual for a Nissan Altima, a 2006 model. The image shows you the ABS control unit here, the computer, and then it shows you here the 4 speed sensors. You can see they are labeled very well. And then in here it shows you the coils for the ABS actuator. Now the ABS actuator has coils, 8 of them, 2 for each wheel, for controlling the brake pressure to each wheel, as you see here. This, for example, is for the front left wheel, so is this, but this first one is for pulling the valve in. This is for pulling the valve out. Now when it pulls the valve in, if you let me explain that we have a motor here as well, that will be running in the actuator. That motor, its job is to increase pressure as determined by, to increase brake fluid pressure as determined by this model, by the control module here. How does it do it? If it lifts, if it tells, if this computer instructs this coil, for example, to actuate by giving it, by sending a current through it, this valve will actuate, will move in a direction which will increase the brake pressure, for example, to the front left speed wheel. If it wants to release that wheel, for example, if it is sensing this wheel is planning to lock, it will actuate this coil instead, which will release the pressure that this motor is building up. The rest of this is just showing you how this motor, rather how this motor and the solenoid valve solenoid valves are operated by these relays, again on instructions of this ABS module. You can see that these relays are controlled by this computer through this wire. You have the battery here, and you have 12 volts coming here, but that 12 volts won't come through to the motor to run the motor until the computer sends a current through this coil, which will trigger this switch, which will close, allow 12 volts to come through here, go through the motor, and as you can see, you have 12 volts on this side and you have a ground on this side. You see this wire, how it's going? It ends up on the chassis somewhere on the ground connection. So these relays are important for when this computer wants to actuate this motor and these valves. And this is a stop lamp switch. That is a switch which turns on your brake lights. It's important because the ABS computer needs to know when you apply the brakes, so it will make these guys ready to operate, to make sure you don't lock. And then we have some wiring here going to the CAN communication. That's the controller area network. And then we have the 3 wires going to the data link connector. Now the data link connector is usually where at Talk to Micah we will put our diagnostic computer to ask this ABS unit, hello, how are you? Any problems? If it has any problems, it will give us codes. For example, if this wire is broken here, it might tell us this guy is not good, he's not alive, and we shall get all that data through here. There's this DLC has the protocol it uses in the communication between the computer, this ABS computer, and our computers at Talk to Micah. There is a protocol they use, so don't expect to get any data here by just plugging in any computer. And then here we have the light, the warning light, the dashboard, which is to warn you when there is a problem so that you bring the car to Talk to My Car. So if there is a problem with any of these guys, or these relays, or these sensors, this computer will send a current through this guy here, the light on your dashboard, and it will warn you to bring the car, talk to my car. Now, in this image, is for example, for this car, is the entire circuitry, and if I were to plug our diagnostic equipment into this 2006 Nissan Altima, if it had the ABS check light coming on, if we were able to read the codes, and I have this diagram that you're seeing here, it will be very easy for me to follow the circuits and find out where the fault is happening. Usually the codes will be enough to guide me to the general area of the fault, but this diagram will help me to understand the circuit properly. So if you too interested in doing diagnostic work yourself, if for example you came to talk to my car and we read the codes for you and you had this diagram, if you have understood this basic operation of the ABS system, it will be a bit easy for you to repair the system yourself. Of course, you deny us a bit of money with respect to that, but hey, we are here to teach you guys how to fix these things. Right, and here is an example of ABS at work. This guy here doesn't have working ABS, so as he's being pulled into the water, he's not having any pulse setting in his pores, and you know, he's just 100% braking all the way now. He's lucky he's just being dragged in a straight line by his owner here. But if this was a car, it could take any direction. It could take the easiest direction. If this, for example, was a curve and the car was at this point, it would just continue in that straight line, just like the dog is doing. So this guy here, on the other hand, you see what he has been doing? Yeah, that's more like how ABS works. He's still, you know, resisting though, just like this guy is doing. But he's able to move sideways if he wished. He would safely be able to move either this way or that way. This guy has no option. If he's being dragged in a straight line like that, he just continue in the direction in which he's being dragged. But this guy here with working ABS has options of even going sideways like that. Yes, thank you for viewing this introduction to how ABS works. Hopefully you've gleaned some information on how ABS on your car works. We are here to save you time, money, and headaches when you're dealing with your vehicle. You can always join us at our Facebook forum at this address down here. Thank you.